Welcome to this lesson on acceleration due to gravity. Today, we're going to explore one of the most fundamental concepts in physics: why all objects fall at the same rate on Earth. The standard value we use is 9.8 meters per second squared, commonly written as g equals 9.8 meters per second squared. So what exactly is acceleration due to gravity? It's the acceleration experienced by any object when falling freely under Earth's gravitational pull. Whenever you drop something, it doesn't fall at a constant speed. Instead, it keeps getting faster and faster. This increase in speed is caused by gravitational acceleration. On Earth's surface, the acceleration due to gravity has a standard value of 9.8 meters per second squared. For simplicity in calculations, we often approximate this as 10 meters per second squared. This means that every second an object is falling, its velocity increases by approximately 9.8 meters per second. Let's break down what 9.8 meters per second squared actually means. Every second that passes, the falling object's velocity increases by 9.8 meters per second. This acceleration remains constant throughout the fall, as long as we ignore air resistance. So after 1 second, an object is moving at 9.8 meters per second. After 2 seconds, it's moving at 19.6 meters per second, and so on. Now here's the fascinating question that puzzled scientists for centuries. Why do all objects fall at the same rate on Earth? Whether it's a feather, a tennis ball, a basketball, or a heavy brick, in the absence of air resistance, they all accelerate at exactly 9.8 meters per second squared. This seems counterintuitive because gravity pulls harder on heavier objects. So why don't heavier objects fall faster? To understand the answer, we need to recall Newton's second law of motion. It states that force equals mass times acceleration, written as F equals m. This fundamental equation tells us that the force acting on an object is equal to its mass multiplied by its acceleration. This relationship is key to understanding why all objects fall at the same rate. Here's the crucial insight. The gravitational force is proportional to mass. We can write this as F equals mg, where F is the gravitational force, m is the mass, and g is the acceleration due to gravity. Now, when we solve for acceleration using F equals m, we get a equals F divided by m. Substituting our gravitational force equation, we get a equals mg divided by m. Notice what happens. The mass cancels out. This leaves us with a equals g. This mathematical cancellation reveals something profound. The acceleration is the same for all objects, regardless of their mass. Let's summarize the key takeaway from this lesson. All objects fall at 9.8 meters per second squared on Earth because gravitational force and mass are proportional to each other. When we calculate acceleration, the mass cancels out, making acceleration independent of mass. This elegant relationship explains why a feather and a hammer, when dropped in a vacuum, hit the ground at exactly the same time. It's one of the most beautiful demonstrations of how mathematics reveals the underlying simplicity of nature.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.